will be explaining you the technology on these communication solutions. I'm joined by my colleagues, my system engineering head, Shashendra Pandey, is a part of this call.
Good
Then
morning.
we have three engineers. They will cover three different topics. So Sauleram Kharmale, who has joined the call, he will be covering the power line carrier communication portion. We will have Anil Karade, he will cover the fiber optics systems. And then we will have Shri Krishna Kumar, he will be covering the wireless portion. That is mainly for the distribution. Now, if we look at power utilities per se, power utilities for the last, I would say, 5 to 6 decades have been, Hitachi Energy have been giving solutions to them. And there are two parts to this. One is the long distance communication. So long distance communication, this was started with power line carrier. So we will be explaining to you the details of power line carrier. And nowadays, it is a mix. It is a mix of power line carrier and fiber optics, because in many places you will find the earth wire is embedded with the fiber optic cables. So there is it is called as OPGW, or optical fiber ground wire, and you have fibers embedded into the earth wire. So you have a mix of systems operating nowadays in long distance transmission. One is the power line carrier, one is fiber optics. Then we have the wireless systems, which are basically the mesh communication systems, and these are meant for the distribution applications. So you will find a lot of ring main units all across the city streets, and these ring main units communicate in wireless form to the nearest substation, from where it is again then taken over the fiber optics to reach the control center portion. So all the three systems will be explained to you, and we as Hitachi Energy are able to offer you a complete solution. We can either offer you, if you ask, part by part solution also, that if there could be customers who ask only power line carrier, there could be customers who ask only fiber optic systems. There are also customers who ask only the wireless thing. And there are customers who ask a complete mix. Now this mix today happening is rare, basically because most of the power utilities, they have got trifurcated, and you have the transmission wing separate and distribution wing separate. But in case there is a utility, then you are able to give one complete solution to the power utility. So with that, I will now give it to Mr. Sauleram Kharmale, who will start with power line carrier. And at any moment of time, you have questions. We are a small group. You can ask those questions, or if you want, you can type out your question in the chat box, and at appropriate time, we will answer those questions. I think our presentation is tailor-made to around 2 hours or so. We are okay if it gets slightly extended. There are no problems. Okay. So I think, Sauleram, you can start.
Yeah, so thank you, sir. So Sauleram Kharmale here from Hitachi Energy. So participants, I'm with Hitachi Energy for more than 15 years, work with the service team, commissioning of equipments at site, PLCC, FOD equipments, and even the wireless. And I work with the manufacturing team, sales team. Currently, I'm working with the system engineering team. Taking care of fiber optic communication, PLCC. So today, I'll take it through what is the power line carrier communication systems, how it is implemented in the transmission, and in some cases in the distribution as well sectors. So we'll move to the next slide. The next slide is about what we are going to cover in the presentation. So first we'll see what are the communication medias used in the substation environment between the substations, and what are the applications the customer seeking in the substation environments: speech communication, data communication, and mission critical communication, that is to operate this transmission line. And then we'll see why the PLCC come into picture. What are the advantages of the power line carrier communication in the substation environment over other communication media or the solutions. Then we'll see what are the things in the PLCC system. and the narrowband portfolio of Hitachi Energy, what we offer under this narrowband requirement. Then some components of PLC systems that will see how the communication happens and what are the components, okay, taking parts in that communication system. And then, okay, there is one component, the coupling device. So we'll see the coupling arrangement of that coupling device. So that we'll see in the details in next slides. Then line trap, okay, one more component is there in the PLC system. So we'll see its components, its functionality in the next few slides. Then, okay, another component is a CVD or CC, what we call as capacity voltage transformer. So we'll see what are the things to be taken care while designing the system, and then the coupling device and its components. And we'll see what are the things, okay, impacting or improving the PLCC performance. And signal attenuation is okay. The signals are traveling on the power line. So we'll see what are the factors impacting the attenuation of signal in the power line. And then earthing practices for communication equipment in the substation environment, and the power supply requirement for the communication equipment in the substation environment. Okay, so this will be our total context content of presentation. If you have anything apart from this, you can ask a question anytime. So I'll move to the next slide. It's okay here. So what are the communication media generally used in the substation environment between the substation? What are the things? Say at the transmitter and receiver is always there, okay, to make the communication. So transmitter and receiver is required, and mainly you need a communication media to transmit whatever the signal, speech, protection, any kind of data you want to transfer, you need a communication media. So here we can see radio system is there on the bottom side. So radio system earlier, okay, nowadays it is got replaced, or it is okay removed and replaced with the fiber optic communication. And some cases it is okay, electrical copper wire or power line carrier communication is used. Radio system is mainly earlier it was microwave links. So now that got okay, that particular frequency band is now freed up, and it is okay given for 4G or 5G communication. So no, nowadays no, okay, this particular radio system is not being used for this substation environment. So here the fiber optic cables are also used as a media. So that is also there in substation communication. And electrical copper wire very rarely earlier stage, okay, it was used for a shorter distance, 10 kilometer to 20 kilometer distance, electrical copper wires. And on the top power line carrier communication, where the media here itself a conductor, power conductors are used as a media to transfer the speech, protection, and data application to the remote end substation. Any question on this slide? Shall I move to the next one?
Sir, hello.
Yeah, yes.
What are the use of narrowband? What mean?
Narrowband communication means here, okay, the communication, the data transfer and all is happening in the kbps. So where we are now talking about the gigabit data transfer or megabyte data transfer, that comes under the wideband. So mainly fiber optic communication, which has okay, we call it as a wideband communication. So narrowband communication has only one channel of speech or two channel of speech communication. So that is what is okay, narrowband communication.
That is interchange.
Interchange means
Communication between two. Hello.
hello, yeah.
Yeah, communication between two person.
Yeah, communication between two person, okay, that we can call as a narrowband, but okay, uh, and communication, okay, it depends, okay, how much bandwidth is okay available for user. Okay, if it is point to point, okay, single user. Yeah, Pandey,
Yeah,
sorry.
Pandey here. See, when we say narrow band, basically we talk of 4 kilohertz bandwidth per channel. Okay, that 4 kilohertz bandwidth is divided to be used as speech and data and teleproduction also. So being narrow, when we say narrow band, there is in one terminal, you can handle one or two or in maximum 3 channels in per trans receiver. Okay. And overall band available for power line is from 50 to 500 kilohertz in India. Correct. And when you compare this to fiber optics or maybe microwave, okay, we will have a number of channels. It's difficult to count. In fiber optic, you can go up to thousands of channels. So that's why this power line is known as a narrow band. It caters to very few channels, right?
That's
Yeah, sir. Thank you.
Sir, one question, sir.
Yeah. Go.
Which types of fiber optic cable is used? Step index or graded type index?
Here, okay, the within a substation communication, say within a one building, we use the multi-mode cable, but between the substation, we use a single mode fiber optic cable. As okay, it has its own advantage, disadvantage. Like a single mode fiber, okay, is has advantage as a lower attenuation on the transmission of optical signal, but it is costlier. But multi-mode fiber is less costlier, but it has more attenuation to the optical signal. So that particular fiber we use in the within a substation communication, connecting to two different switches or some devices in a one building. So we use a multi-mode. Whereas, okay, a single mode fiber is used between the substations. If the distance is 10, 20 kilometer or 100, 200, 300 kilometers. And graded index, okay, it is again the costlier solution, so that we are not using.
So step index also used in substation.
Pardon?
Step index types of fiber optics is also used or graded index.
Graded index is okay. Here the refractive index is okay, changing at every instance, and that manufacturing of that particular fiber is costlier. So we use only two types of fiber, multi-mode and the single mode fiber.